Welcome to your Mentor One. Today let's discuss about renewable energy sources. Renewable energy sources are natural sources that are inexhaustible and can be replenished naturally. They produce less pollution and are eco-friendly. They are the key to a sustainable and green future. The renewable energy system includes different energy sources such as solar energy, wind energy, hydropower energy, biomass energy, geothermal energy, wave energy, ocean thermal energy. All these sources contribute to clean electricity generation. Working step by step. Step 1. Energy is captured from a natural source. Step 2. It is converted into mechanical, thermal, or electrical energy. Step 3. The energy is conditioned and regulated. Step 4. Stored, if required, in batteries or other storage systems. Step 5. Supplied to loads or fed into the grid. Advantages and disadvantages. Advantages: abundant resources, low fuel cost, clean and eco-friendly, renewable and sustainable, high efficiency, hydro, reduced pollution, continuous energy generation, geothermal. Disadvantages: high initial cost, depends on natural conditions, land area requirement, intermittent nature, solar, wind, environmental impact in some cases. Location-specific installation. Applications: electricity generation for homes, industries, and agriculture. Rural electrification and off-grid power supply. Water pumping and irrigation. Street lighting and traffic signals. Electric vehicle charging stations. Industrial processes and heating. Solar power generation. Solar power generation uses sunlight to produce electricity. It is a clean, renewable, abundant, and eco-friendly source of energy. Solar energy reduces dependence on fossil fuels and helps in reducing electricity bills. Working principle: sun rays, solar energy, are absorbed by solar panels. The solar panels convert sunlight to DC electricity. The DC electricity is converted into AC electricity by an inverter. AC electricity is used to run home and industrial appliances. Excess electricity is supplied to the grid or stored in batteries. Types: classification. A. Based on technology. Solar photovoltaic, PV, solar thermal, heat, solar thermal electric. Off-grid solar power plant. On-grid solar power system. Hybrid solar power system. B. Based on connection. On-grid solar power plant. Off-grid solar power system. Hybrid solar power system. C. Based on scale. Small-scale, rooftop systems, medium-scale, community systems, large-scale, solar power plants. Working step by step. Step 1. Sunlight reaches the solar panels, PV cells. Step 2. PV cells convert sunlight into DC electricity. Step 3. DC electricity is regulated by the charge controller. Step 4. If storage is needed, electricity is stored in batteries. Step 5. DC electricity is converted into AC electricity by the inverter. Step 6. AC electricity is supplied to loads or fed to the electrical grid. Advantages and disadvantages. Advantages: renewable and abundant source, no fuel cost, environment friendly, no pollution, low maintenance, modular and scalable, silent operation, long life. Disadvantages: high initial cost, power output depends on sunlight, requires large area for installation, battery storage increases cost, not suitable at night without storage. Applications: residential rooftop power systems, commercial buildings and offices, water pumping and irrigation, street lights and traffic signals, telecom towers and repeater stations, battery charging stations, solar power plants, etc. Wind power generation. Wind power generation converts the kinetic energy of wind into electrical energy. It is a clean, renewable, inexhaustible, and eco-friendly source of energy. Wind energy is one of the fastest-growing renewable energy sources in the world. Working principle: wind flows over the blades of the turbine and creates lift force. This lift causes the blades to rotate. The rotating blades drive the rotor, which spins the generator. The generator converts mechanical energy into electrical energy. The electricity is then used locally, stored, or supplied to the power grid. Types, classification: A based on axis of rotation, horizontal axis wind turbine, vertical axis wind turbine. B based on location, onshore wind turbines, offshore wind turbines. C based on application, standalone, off-grid system, grid-connected wind power plant. D based on size, small scale, 1 megawatt, working. Step by step. Step 1. Wind blows and strikes the turbine blades. Step 2. Blades rotate and convert wind energy into mechanical energy. Step 3. The rotor shaft transfers this energy to the gearbox. Step 4. The gearbox increases the rotational speed. Step 5. High-speed rotation drives the generator to produce electricity. Step 6. Electricity is conditioned and supplied to loads, the electrical grid, or stored. Advantages and amp. Disadvantages. Advantages: renewable and inexhaustible energy source, no fuel cost, clean and non-polluting, low operating and maintenance cost. Land below turbines can be utilized. Quick installation time, helps in rural electrification. Disadvantages: high initial cost, power output varies with wind speed, requires large installation area, noise and visual impact, storage or backup required for continuous supply. Not suitable for low wind speed areas. Applications: electricity generation in wind farms, utility scale, rural and remote area electrification. Water pumping and irrigation, battery charging systems, hybrid systems, etc.
Biomass energy. Biomass energy is the energy obtained from organic matter, plant and animal waste. It is a renewable, sustainable, and eco-friendly source of energy. Biomass sources: agricultural residues like rice husk, wheat straw, forest residues like wood, sawdust, animal waste like dung, poultry litter, municipal solid waste, energy crops like jatropha, switchgrass. Types, classification: A. By conversion process, direct combustion, gasification, pyrolysis, anaerobic digestion, fermentation. B. By source, woody biomass, agricultural biomass, animal biomass, municipal biomass. Energy crops: working, direct combustion power plant. Step-by-step explanation. Step 1. Biomass fuel is collected, dried, and stored. Step 2. Fuel is fed into the boiler through the feeding system. Step 3. In the boiler, biomass is burned to produce heat. Step 4. Heat converts water in the boiler into high-pressure steam. Step 5. Steam expands in the turbine and produces mechanical energy. Step 6. The turbine drives the generator to produce electricity. Step 7. Exhaust steam is condensed and water is recycled back to the boiler. Advantages and disadvantages. Advantages: renewable and sustainable, reduces waste disposal problems, low net greenhouse gas emissions, can be used in rural areas, reduces dependence on fossil fuels, supports local economy and employment. Disadvantages: low energy density, requires large storage space, high moisture content, reduces efficiency, ash disposal problems, transportation cost may be high, high initial setup cost. Applications: electricity generation, biomass power plants for grid and captive use, heating and cooling, space heating, district heating, water heating, biofuels, bioethanol, biodiesel, biogas for transport, industrial use, steam and process heat for industries, paper, sugar, textile, etc. Rural energy, cooking, lighting, small power plants for households. Biomass energy is a clean, renewable, and reliable source. It converts organic waste into valuable energy. It plays a major role in sustainable development and tidal energy. Tidal energy is the energy obtained from the rise and fall of sea levels due to the gravitational pull of the moon and sun. It is a renewable, clean, and predictable source of energy. Types, classification: by technology, tidal barrage, tidal lagoon, tidal stream, current turbines, Dynamic tidal power. By operation. Single effect uses either flood or ebb tide. Double effect uses both flood and ebb tide. Working step by step. Step 1. When the tide comes in, the water level inside the basin rises. Step 2. Sluice gates close to trap water. Step 3. When the tide goes out, water flows through turbines. Step 4. Turbine rotation drives the generator. Step 5. Electricity is produced and supplied to the electrical grid. Applications: electricity generation, remote area power supply, desalination plants, water pumping and irrigation, coastal community power. Tidal energy is highly predictable and reliable, making it a valuable source of clean electricity for coastal regions. Geothermal energy. Geothermal energy is the heat energy stored within the Earth's interior. It is a renewable, clean, and sustainable source of energy. Types, classification. A. Dry steam plant. Uses steam directly from reservoirs. Flash steam plant. Uses high-pressure hot water flashed into steam. B. Binary cycle plant. Uses moderate temperature water with a secondary low boiling fluid. Working step by step. Step 1. Hot water. Steam is extracted from underground reservoirs. Step 2. Steam is separated in a steam separator. Step 3. Steam drives the turbine. Step 4. Turbine drives the generator to produce electricity. Step 5. Steam is condensed and water is re-injected into the reservoir. Advantages and disadvantages. Advantages: renewable and sustainable, high capacity factor, low operating cost, small land requirement, reliable baseload power, low emissions. Disadvantages: high initial cost, location specific, possible release of gases, H2S, CO2, scaling, and corrosion problems, risk of induced seismicity. Applications: electricity generation, direct heating, buildings, greenhouse heating, industrial process heat, hot water supply, and spas. Geothermal energy provides reliable, continuous, and clean power with high efficiency and low environmental impact.
Economic operation of power plants. Economic operation of power plants means operating the available generating units in such a way that the total operating cost is minimized while meeting the required demand and satisfying all constraints, technical, environmental, and operational. Why is it important? It reduces fuel cost, improves plant efficiency, extends equipment life, ensures reliable and secure operation. Types or classification. A. Based on load, it's classified into 3. Base load plants, intermediate load plants, peak load plants. B. Based on operation, it's classified into 4. Economic load dispatch, ELD. Unit commitment, optimal power flow, OPF. Working, step by step. Step 1. Forecast the load demand for the scheduling period. Step 2. Determine available generating units and their cost curves. Step 3. Arrange generating units in the order of increasing incremental cost. Step 4. Allocate load to units starting from the lowest cost unit. Step 5. Adjust generation to meet the exact load at minimum cost. Step 6. Check constraints, capacity limits, ramp rate, reserve margin, etc., and redispatch if needed. Advantages: minimum fuel and operating cost, better plant utilization, higher efficiency, reduced pollution, optimum use of resources, improves system reliability. Disadvantages: requires complex computation, needs accurate data, high dependency on forecasting, load variation may affect optimum schedule, constraints may limit economic operation. Applications: daily and weekly operation planning, load dispatch centers, SLDC, RLDC, minimizing operating cost of utilities, hydrothermal coordination, unit commitment and scheduling, integration with renewable energy sources, Load curve and load duration curve. Load curve. A load curve is a graph showing the variation of load on the power system with time. Load duration curve. A load duration curve is a graph showing the duration for which a particular load is equaled or exceeded during a given period. Why is it important? Helps in planning and operation of power plants. Determines plant capacity and number of generating units. Improves economy and efficiency. Useful for load forecasting and scheduling. Types are classification. A. Based on time period, it's classified into 4. They are: daily load curve, weekly load curve, monthly load curve, yearly load curve. B. Based on nature of load, it's classified into 4. They are: industrial load curve, commercial load curve, residential load curve, agricultural load curve. C. Based on presentation, it's classified into 2. They are: 1. Load curve, load versus time. 2. Load duration curve, load versus duration. Working, step by step. Step 1. Record the load data at regular intervals, e.g., every 15 minutes or 1 hour. Step 2. Plot load versus time to obtain the load curve. Step 3. Arrange the recorded load data in descending order. Step 4. Plot load versus duration to obtain the load duration curve. Step 5. Calculate important parameters such as maximum demand, energy consumption, load factor. Step 6. Use the curves for plant scheduling, capacity planning, and economical operation. Advantages and disadvantages. Helps determine plant capacity and number of generating units, improves plant utilization, useful for economic operation, helps in load forecasting, provides an idea about demand pattern. Disadvantages. Requires accurate data collection, demand variation makes prediction difficult, does not consider future load growth. Applications. Planning of new power plants. Determining size and number of generating units. Economic operation and scheduling. Unit commitment. Load forecasting and demand analysis. Tariff determination. System reliability and expansion planning. Thanks for watching. Follow for more videos.